Hello, I'm Robert, and this is the third part of this talk on many reasons not to live on Mars, great place to explore. So this might be a good time to take a little bit of a breather and review what I've said so far in the talk. So we found out that Mars is so very cold that it would be a snowball Mars, it would be white, if it wasn't that it's also so very dry. And part of the reason why it is so very dry is because the atmosphere is so very thin. And the atmospheric pressure is well below the Armstrong limit, and it means that not only does water boil at blood temperature over most of the surface of Mars, then ice will sublime directly into the atmosphere. Ice will turn directly into water vapor without ever going through a liquid phase. And the atmosphere is so thin that it's well beyond the limit of human survivability. You would die very, very quickly without a spacesuit. It would just be like going outside of the ISS, the International Space Station, without a spacesuit. Then there are other reasons why it's not such a nice place to live, and in particular the atmosphere is this kind of dull reddish brown colour on Mars, and this filters the light, and the landscape is basically a kind of reddish colour anyway, and to human eyes it just looks, stretching out as far as you can see, just reddish greyish browns, just very slight changes in shade of reddish greyish brown, and just one shade of reddish greyish brown, another shade of reddish greyish brown. This makes it difficult to distinguish features, and it makes it difficult to distinguish any colours. In order to see it in the same way as the digitally processed images that you see in the news stories, you would need to have a digitally enhanced vision. Perhaps you'll have to put on goggles in order to see the landscapes of Mars properly. Then, every 2 years, you have the dust storm season, and during the dust storm season, then if you have a long dust storm, then you can have 99% of the sunlight blocked out, and that's for weeks on end, and you can't see anything at all. Then we also saw that there's the supply chain problem. So suppose that you're on Mars and something goes wrong with your spacesuit, and you can't repair it on the spot. So you're now stuck in your habitat and you can't go anywhere. Well, the next replacement that you can get from Earth, at the worst case scenario, then you might have to wait 2 years and 6 months for a replacement. That's because from when they hear on Earth that you need a replacement, then it might be 2 years from then to the next opportunity to be able to have the two planets aligned right, so you can send a spacecraft from one to the other, and then another 6 months for the spacecraft to get to you. And then you also have that you would be dependent on highly technical, lots of complex machinery. And for instance, the ISS has gone wrong several times, and they have sometimes needed to be supplied with emergency oxygen from the Earth. This would not be possible on Mars, and this would become an Apollo 13 type incident. And in those circumstances, then the situation might develop very quickly, and you might need some urgent support from Earth. Then the light speed delay comes into play, which is that you have, it could be up to 40 minutes delay. You ask a question to Earth and it's only 40 minutes later that you hear from them, and it could take quite a while for Earth to understand the situation very well, and for you to understand what they're suggesting as the way through. And then if it doesn't work quite as you expected, then it could be even more. You can imagine disasters developing very easily in Mars. All this suggests that Mars is not an ideal place for starting colonization. It's a place for hardy explorers, and people like the Apollo 11 astronauts who are able to deal with these kind of situations. And then also there's the problem that even though it is so very extremely hostile on the surface for life, nevertheless there is some possibility of life living there on the edge, very much on the edge. Most remarkably are these lichens, and that they're able to just use the moisture from the atmosphere when it is at high humidity as the atmosphere cools down. And then there's also the possibility of subsurface brines, which they work by deliquescing. It's a somewhat similar process as, again, at high moisture. And then also the warm seasonal flows. So the various possibilities, there might actually be habitats for life on Mars, and there might be present-day life as well, although probably very hard to spot. And all this means that any human being landing on the surface of Mars, there's a great chance of them contaminating the surface, certainly far more than the rovers that we send there, but it seems that the chance might be very high, and especially so since just a single strand of DNA, the experiments we're sending up there, that we want to send up there, they would be able to detect a single amino acid or a single strand of DNA in your sample. You don't want human beings anywhere near something like that. And you also have the problem that if there's a contamination at a human landing site, then this can be spread anywhere on Mars in the dust storms, which being made of iron oxide, and the dust storms very dark, cracks in this dust. This was a concern of Carl Sagan, that this could spread microorganisms anywhere on the surface of Mars. So it seems that absolutely you should not send human beings to the surface of Mars until this is thoroughly understood whether by doing so they would indeed contaminate the planet, as seems very likely, and whether contaminating the planet with Earth life is what you want to do. So all that needs to be sorted out. It mustn't happen by accident. We mustn't send human beings to Mars and just find and monitor what happens and find that we have contaminated Mars. So I suggested that we should send hardy explorers to Mars that are able to in some way explore it without contaminating it. And that's a big question. How is that possible? Because there's no doubt that human beings on the surface is the very, very best way to explore a place. But then it gives another question, so we'll come to that in a minute, and what can be done about that. But then that will be in the next talk, I think, in the next part of this talk. And in this part, I'm particularly looking at what are the alternatives for colonization, and where is the best place in the solar system for us to colonize. Now, if you're looking for new places for human beings to live, well, I showed you last time, I showed you the McMurdo dry valleys. For a bit of a change, this is the Atacama Desert, and this is the other area on the Earth which is regarded as perhaps one of the closest analogues to Mars that we have. That is because it is so very high. It's got a thin atmosphere and it's very dry there. For that reason, it is ideal for infrared astronomy, and this in fact is a photograph taken by the European Space Observatory. It's somewhere around the European Space Observatory telescope in the Atacama Desert region. So it's extremely dry, and it's as you can see, it's a cold place as well, and cold and dry, and the only main difference really, well, the climate is a bit different of course, and this is the atmosphere. So the atmosphere is far too thick for Mars. And again, surprisingly, just as in the McMurdo Valley, you get life in the Atacama Desert. Life that is quite hard to detect. And there could be no doubt, I think, that this is far more hospitable for colonization than anywhere else in the solar system outside of Earth. Except very possibly things like the seas of Europa, very distant places. So if you want to find somewhere new to live, then far better than colonizing the solar system is to colonize the deserts on Earth and use all the same ideas that we had in mind to colonize Mars. And you can use the desert sands to make glass for your greenhouses, and you can do all the things that were suggested for Mars, but do them on Earth. And it'll be far, far less cost, and far more people would be able to live there than in your few tiny habitats on Mars. And so you might first think then, it's a way to do that, you might first of all think something like BIOSPHERE 2. So this is the project that is perhaps closest what you would be wanting to do on Mars, of things that be done on Earth. The idea was to have a completely enclosed biosphere and to generate all the oxygen from the plants and to grow all their own food. But as it turned out, they weren't able to produce enough oxygen and they weren't able to produce enough food. And so this experiment was brought to an end, but learned a huge amount from it. And it's now, in terms of space habitats, ideas seem to have turned rather more to more technical ways of using hydroponics and things like that. But perhaps eventually we'll come back to something like BIOSPHERE 2. Anyway, you could, for far, far less cost than a Mars mission, you could set up many colonies of BIOSPHERE 2s on the Earth. Things like this, maybe the next step along. And you don't need to worry about the keeping it self-contained, especially the oxygen, because the oxygen you can obviously get from the Earth atmosphere, unless you're particularly doing it as an experiment as a first step towards colonization of space. We also have resources on Earth which we don't have on Mars. Apart from the oxygen in the atmosphere, we also have seawater. Many of the deserts on Earth, they're close to the sea. And this is the Seawater Greenhouse. And this, the way it works is you have water that comes in from the deep sea, and so it's cold. It comes in, it helps to cool down the greenhouse in the very hot desert sun. And the hot desert sun also causes the seawater to evaporate. This keeps the humidity high inside the greenhouse, provides water inside the greenhouse, and it provides so much water that there's too much water for the greenhouse, and this water can be used for irrigating the desert outside of the greenhouse and grow trees outside it. This is a very interesting project because there are many projects, of course, to green the desert, like in Israel and various parts of the Sahara Desert, some of the very advanced projects where parts of the desert are being greened by using irrigation, using subsurface aquifers from the desert. But these can be a bit controversial sometimes because the question is you're using up water that's from deep underground. And so you have to look at a case-by-case basis whether this is a wise thing to do. This is very interesting though, because it doesn't do that. It does the opposite. It actually contributes water to the desert. So as a result of building this project and leaving it running, you're getting water continually irrigating the desert, and it comes from seawater, and it's not using any subsurface aquifer, it is replenishing them if there is any. So that is the Seawater Greenhouse. So it's a very interesting project for basically colonizing the deserts of the Earth. And now this is the Sahara Forestation Project. They only have a small pilot plant at the moment in Qatar, which is basically the Seawater Greenhouse idea, seeing how it works. This is an artist's impression about how this could develop in the future. So this shows a huge area of greenhouses in the desert, close to the sea, supplied by the seawater, and then these show the trees that are being grown by irrigated using the excess water from the greenhouses. And the greenhouses, they produce crops, they also produce algae for fuel, and this could support many local people. So for the cost of a very small colony on Mars, you could have large areas of the desert with these greenhouses projects. You're talking about billions of dollars, and I'm sure you could cover large areas of the desert with these seawater greenhouses and it could support many people on the Earth. And it'd be an extra colonization, and it's reversing desertification and so forth. So if you're looking for somewhere to live, then most definitely the Earth is still the very best place in the solar system to go to colonize. There's also below the sea, beneath the sea as well, especially the shallow areas of the sea where there's light from the sun as well. So there are many ideas to actually colonize the seabed, and this is much less advanced than the ideas of reversing desertification of the deserts. But potentially, long term, that is a very large habitat where human beings could live as well. And especially in the shallower seas. Of course, there are also lots of questions about conservation of the seas, but I mean that's the same question you have on the land as well. So it would have to be carefully done, and but certainly it's certainly possible in the future that you could have colonies on the base of the sea, and again you could start a very large subsea colony for the same cost as starting up a mission on Mars. So this suggests that if we're going into space, then we're not going there because we're looking for somewhere to live. We have some other reason for going into space. So you might do it because you are a hardy explorer, and then you like the Apollo astronauts, and then you would be heading anywhere in the solar system, including Mercury, Venus, Jupiter and so on. And you take extreme risks and so forth. Or you might be going into space because you're a tourist and you want to go out and just visit space. And you might be going into space because you want to mine the resources in space. Or you might be going into space because of the science value and because you want to study it. And then finally as well, you might also want to go into space because you're an artist and you want to paint the landscapes there, or because you're a musician or a poet and you're going to be inspired by the space environment. I think definitely space is not a place only for scientists. However, it does have tremendous science value, and so there may be many, I imagine that's probably going to be quite a strong driving force to start with. Well, so where then are we going to go in space if we're going to colonize space and set up these first colonies for the tourists and the scientists and the miners and so forth? Well, the obvious place on the surface of a planet is the moon, especially because you've got stunning landscapes as well. So then you've got the possibility of the space tourists. It's very easily accessible. There's none of the supply problems of Mars. There's none of the communication problems of Mars. And it is turning out that it is far more interesting than it was originally thought. The landscape is bright, so you don't have the dull landscape of Mars. So you don't have the problem of possibly getting depressed because it's so dim there all the time. And we know surprisingly little about the moon, considering how much exploration has gone on. And what we're discovering is becoming more and more interesting as we find out about it. This is a picture of this is from the Apollo 15 mission to the moon. And you can tell by the rover that it's not the very first, not the Apollo 11, they didn't have one. And the first people who were sent to the moon, they were all fighter pilots from the US military. Highly trained people, able to respond to an emergency and able to keep calm in conditions of extreme danger. Fast-thinking people and resourceful people, and this is exactly what was needed for the first people. If you're going to send humans to the moon, that is exactly what was needed. However, as the lunar missions progressed, then towards the end, then it was considered safe enough to start sending the very first scientist to the moon. And he was also the very first non-US military astronaut. But before then all the previous astronauts you're talking about jet fighter pilots up there, and science they weren't noted for their notable scientists. They were notable jet fighter pilots. And this means that nearly all the rocks that were returned from the moon were returned by jet fighter pilots. And you may look at this and you see this wonderfully clear picture of the moon. However, this was not available to the people on Earth at the time. This was taken with a film camera, which had to be developed and then printed. We didn't have the technology then to transmit a photograph like that from the moon all the way to the Earth. And the actual pictures we saw of the moon, they were very low resolution and quite hard to make out, with quite a lot of interference as well. It certainly wouldn't have been possible for geologists to give detailed advice about which rock to pick up. So the only lunar rocks that were returned by geologists was with the very last mission. And one of the rocks that he returned has been dubbed the most interesting rock that has been returned from the moon, which is no surprise, and any of the other astronauts, they would have walked straight past it, no doubt, and not realised it was so interesting. So, although we have had so many missions to the moon, we haven't had very much by the way of science missions to the moon. It wasn't science-led. And Carl Sagan, he was interested in the science value of the missions above all, and he argued against sending the humans to the moon. And then once the humans were there, then he argued very strongly to maintain and to continue with sending more humans to the moon. And the reason was that he was saying that having designed the lunar module and all that, and all the complex methods and the command module and all that, that was the expensive bit. Having done that, we could then churn them out, and it cost much less to create more of those. And each mission was just, it was counted in millions, it wasn't counted in billions, or maybe tens of millions, I can't remember the figure, for each new lunar mission. And so he said that it was a bit like building a Rolls Royce. And then you just take it for a few spins around your town, and then you just leave it in a garage, and then you forget about it. And that basically is what we did with Apollo. And after the very last of the Apollo missions, then simply nobody has returned to the moon. And there can be no doubt that if there had been scientists sent to the moon, then we would have found out a tremendous amount more about the moon than we can at present, using just orbital missions. And it has turned out that the moon is far more interesting than we thought it was during the Apollo missions. So one discovery has been that there's there's surprisingly more water on the moon than was realised. There is, first of all, there is a small amount of water in the regolith, which is the area of dust and small rocks on the surface of the moon. There's, in the regions which the Apollo astronauts visited, then especially near the equator, then it's a very small amount, maybe a couple of tablespoons per ton. As you get towards the poles, then you're talking about a kilogram per ton. Now, you can also extract metals from the lunar soil, and you can also, as a byproduct, you get oxygen. Actually extracting that water, just processing it in order to get the water, would probably be not terribly feasible, but if you are also doing other things like generate oxygen and metal as well at the same time, and processing in various ways to create your habitats, then you can well understand that perhaps this 1 kilogram of water per ton might be a useful amount of water on the moon. And then there are also the other possibility of water at the poles of the moon, and in this case it's considered as there might be as much as 5% by weight of water when you get to the perpetually shadowed craters near the poles of the moon, which I like to call the craters of eternal night. Anyway, before talking about that, let's talk a little bit more about it turns out that probably the poles are the very best place to colonize, but let's talk a little bit about the more equatorial regions and some of the challenges and interests of that. So first of all, of interest, for your space tourists, you have actually rather interesting mountains and things. It's far more interesting than you might have guessed from the first Apollo missions, because they deliberately target very flat areas of the moon. So you do have mountains. They're created by the craters, sometimes in the middle of the craters, and also the rims of the craters. You also have lava tubes, and you have caves within the lava tubes. And you have the rills. So it's quite a varied landscape, really. Then at night, you have the wonderful starry night, surely. You'll be able to see the Milky Way and all the stars, very bright. And then if you're on the Earth side, you would see the Earth slowly turning in the sky. So it could be a very nice place to live, in some ways. There are other things that make it a little bit not so nice. Particularly, you have the sunlit, when it's in the sun, then it gets very hot. And here, the ground would be over 100 degrees centigrade in temperatures. At night, it is extremely cold. And so you have to be quite careful with your habitat to deal with that. And so your habitat would have like a covered with the lunar soil, which would also help to protect it from cosmic radiation, or you might possibly build it within one of the caves on the moon, especially the first habitats. Then you also have the problem that you have no solar power during the night. And the usual way of solving that is to have some kind of nuclear power station, some kind of use of fission power. That's not such a problem on the moon as it is on the Earth, because you don't have any natural system that could be contaminated. So it's not really too much of a problem having nuclear waste on the moon, because wherever it is, it's just going to sit there. I personally, although I am very concerned about nuclear power on the Earth, until it is well developed, I'm not so concerned at all about nuclear power on the moon, because there's no ecosystem to be contaminated by it. However, there's one other way of supplying power to equatorial regions. Now, I'm going to clearly label whenever it's an idea of my own, rather than an idea that I've seen in a paper or something like that. And this is one of those. So this is combining various ideas. So there's the idea of solar panels in the Sahara Desert. Many of those could supply electricity to the whole of Europe, because you can, if you have the right kind of cables, you can supply electricity over hundreds, thousands of kilometers. And so it would be possible to supply electricity for the whole of Europe from solar panels in the Sahara Desert. And this could be an export of the Sahara Desert, especially as the prices of solar panels continually going down. Well, so then I thought, well, combine that on the moon. The problem on the moon is that you've got the sunny side and you've got the dark side. And the dark side, for 14 days, you are in the dark side. So as it rotates around, you go into the dark side and you go back to the sunny side. And so for 14 days, you are in the dark side of the moon, which is sometimes facing the Earth and sometimes facing away. Well, build a whole lot of solar panels all the way around the lunar equator and join them together by a long-distance transmission cable. And on the moon, you don't need to worry that people are going to trample over it or anything. Just lay it on the surface. And to deal with the micrometeorites, then have it more like a kind of band. So lots and lots of them, little ones, or some kind of fabric or something. And then a conducting fabric would maybe be best of all. Then micrometeorites are just going to cause holes in it. And then from time to time, then you can send engineers to repair it, to repair the effect of all the micrometeorites. And so in that way, you can have solar power over the entire surface of the moon. and then run transmission lines from that to wherever else on the moon. So I think long term this power supply isn't going to be a problem. Surely something like that could be done. I don't see any problems with that plan. If it's going to work on the Earth and from Sahara Desert to Europe, then surely you can supply power from the sunny side of the moon to the dark side of the moon. So long term, the moon does seem a considerably more habitable place than was thought before. It's also very interesting. So you might be very surprised to know that the moon is also interesting for the search of the origins of life. And you might wonder, how could the moon be interesting in that respect? Because it's completely hostile to life. Here, when you're near the equatorial regions, then it is very dry, and what water there is there, it's not available to life. This water that they've discovered. And then at the poles, if it's in the form of ice, it would be available to life, except that it's so extremely cold, and that's why it's in the form of ice. So it's way beyond any possibility of life taking any advantage of it, as far as we know. So why am I saying that we could find out about the origin of life on the moon? Well, this may give you a clue. And this is an artist's impression of the 10-kilometer across meteorite impact that in Mexico, in what is now Mexico, it's believed you can trace out the impact crater, and you can trace the effect of it all over the Earth. And this is thought to have sent debris. This is the impact that contributed to the extinction of the dinosaurs. It's thought to have, and this would have sent debris. It was such a big impact, it's thought that it very probably sent debris into space with escape velocity. So quite a lot of that could have hit the moon. Some of it might possibly have hit Mars as well. We are talking about a very small amount of debris that would actually get that far. Obviously most of it would end back on Earth, and even if it goes into space, eventually it comes back to Earth again. But a small amount could have hit the moon. So it's now another of my wild ideas. The general idea is that this debris and it's also the material that gets sent with the highest velocity is from the very edge of the forming crater, and it gets sent off with very high speed but only lightly shocked. So it's really rather ideal for preserving life in it, at least as ideal as you can get, given that the life is going to be sent off by a meteorite impact. And it's thought it could certainly have preserved microorganisms, DNA and microorganisms. And my rather wild idea is it possible that it could even preserve chunks of multicellular life as well, either bits of plants or bits of animals? And that's maybe a bit speculative, but at any rate, there's definitely this idea that you could explore, that you could find this on the moon. Now, that would be rather little debris that there would get to the moon. You'd have to be very, very lucky to find the debris from the KT impact event. However, you just look at the moon and you can see that the moon has these huge impact craters, big craters, which have then later been filled by the mare, the lunar seas. So it's obvious that there was a time of very heavy, it's called the late heavy bombardment. It's actually very early, but it's late compared with the rest of the bombardment, as it were. So it's this period called the late heavy bombardment in the early solar system, and this is direct evidence from the moon that this occurred when there were huge bodies flying about through the solar system and hitting any of the forming planets and moons. So this was during the time when it's thought that life was starting to evolve on the Earth. So these impacts, that they hit the moon, then these certainly would have been similar impacts on the Earth as well. Far too long ago for there to be any geological record of them, but from the evidence on the moon, it's absolutely certain it must have happened on the Earth as well. And so this would have sent masses of debris into space, and of that debris, a lot of it would have hit the moon. And so it's believed, and this is not my idea, this is generally accepted, that it's believed that very probably on the moon there is the debris of these impacts on the Earth. It might possibly be on the surface, or you might have to dig to find it, and but one way or another, as you explore the surface of the moon, this is something that we may find there. And this gives us a lot of interest for study of evolution, because you could have either fossils or even possibly some organics from that time, if it's sufficiently buried deep enough to be protected from the cosmic radiation, and if it's only lightly shocked and not too much metamorphized on the journey from the Earth to the moon. So the moon is a fascinating place, and I think a great place for if you want to have tourism and have a colony, and it's interesting for tourists, and it's of interest to the scientists as well. The very best place on the moon for your very first colony, before you've sorted out the power issues and so on, is this place. This is one of the peaks of eternal light. And this is where it looks like on the map, as it were, and this is what it would look like from the surface, a simulated view of it on the surface. I think that bright bit would be that bright bit. I think that's where you're looking from, probably. I'm not entirely sure. I think that bit is that bit. I think that is the peak of eternal light. It was a little bit hard to tell from the caption, but I think that is that bright bit there. So this peak of eternal light, it's the poles of the moon, and a certain favoured spot that even though the moon is continually slightly changing its orientation, yet through all of that, through all the complex motion that the moon does, extremely complex motion, they tried to work out the formula for the moon at the end of the 19th century. It ran to, I think, a couple of pages or something, a very, very complex motion of the moon. But through all that motion, these still stay in sunlight. And it may very briefly go out of sunlight. It certainly would go out of sunlight during the lunar eclipses, when the Earth gets between the sun and the moon. But for most of the time it's in full sunlight. This makes it absolutely ideal for a very first human habitat. And it's also a very interesting place to visit, because you have solar power all year round, all day, all night. And it's also a constant temperature, so you don't have to adjust your temperature control system depending on whether it's night or day. And you could grow crops there, because you could have greenhouses and you filter out the light when you don't want it for the nights, and then let it in when you want it for the day. Solar power. It's also in an ideal location for many things. So for one thing, it's got the craters of eternal night just next to it, and those would have the possibly 5% of ice, possibly more than that, because that was just one particular location. So that's great value for colonizing the moon. It's also an ideal location for an infrared telescope that is passively cooled in the darkness of these craters. And then the far side of the moon, then that's an ideal location for radio astronomy. You often hear people talking about the dark side of the moon. There isn't a dark side of the moon for light, but there is a dark side of the moon for the radio waves. And astronomers on the Earth, they have lots of problems with interference. just things like your microwave and cell phones, and sometimes someone might transmit on and some of it leaks, and television channels and GPS, and just leaking into different channels where they're not expected to be. So even though there are channels that are set aside for radio astronomy, still it's quite problematical doing radio astronomy on the Earth. And then there's most of the spectrum you simply can't do radio astronomy, only in these special set aside channels. On the far side of the moon, then you could do radio astronomy across the entire spectrum, and there'd be no interference from the Earth. And it is the most radio quiet place in the solar system, in the inner solar system anyway, because there's no interference from the Earth. So there are good science reasons and good astronomy reasons. There are also tourist reasons and reasons for habitability, while for thinking that this is a very, very good spot for a first colony on the moon. You have to be a little bit cautious, because there's also the idea that you might well have science parks on the moon, areas that you don't want to disturb. And it might well be, for instance, this, again my own speculation, but it might well be that that these areas of ice deposits, that parts of them at least become parts of these science parks. And it's been suggested that the rocket exhausts, these particularly, could contaminate those areas, and you might want to land a little bit away from them. I'm not sure if the peak of eternal sunlight, it might perhaps be far enough away from them, so you could land a rocket there and then send a rover down to explore the craters of eternal night. And you would probably want to do that without any humans involved, though, to start with. And the humans, they can operate from the distance, but not actually on the spot. That's just my own suggestion, but I think there is going to be quite a lot of care taken for the very first processes of looking at these deposits to see what exactly is there. But long term, once the science has been done, and probably very soon after, because it's so close to the moon, with enough funding, we could find out a lot very quickly about the moon. And I think that's probably where the first lunar colony is going to be. Maybe not this particular one, because there are several peaks of eternal sunlight. And there is one problem, just to mention that another of my wild ideas. I see no problems with it. I talked a bit with my Facebook friends, and some of them very knowledgeable scientists and so on, and they see no problem with it. And this was the idea that one of the problems with lunar gravity is the low gravity, and we simply don't know how human beings can adjust to low gravity. When you have zero gravity, like you have in the ISS, certainly you have lots of problems. So you have bone loss, that's quite well known, probably most people know about that. You have the muscle atrophy. They also have problems with their eyes, and sometimes after a long stint on the space station, then they can't see very well. And there's one case in which this, usually it recovers on return to Earth, but there's one case where it didn't. And then you also have potentially long-term cardiovascular problems, and this is all due to the low G, to the zero G conditions that they're exposed to there. And you also have muscle atrophy, which means that when you return to Earth, it takes a while to be able to get back to being able to walk normally and to hold your head up and things like that. Well, we simply don't know whether the lunar gravity would be a problem for most of those, though it seems quite likely that at least muscle atrophy you would have a certain amount of that if you're living in such low gravity. So, and the same of course is all these problems for potentially for Mars as well. And we simply don't know. We have no way to simulate such low gravity on the Earth. In fact, amongst all my disadvantages for Mars, I forgot to mention that we don't know if the effect of the low gravity. But there is a way around that I just came up with this idea, and the idea is to have like an observation deck on the top of a skyscraper, have a spinning deck, or like like a fairground wheel in a fairground, but rather a large one, maybe a couple of 100 meters across. And if you have this slowly spinning habitat, and you spin it at just the right speed, you could generate 1G on the surface. There's no reason why you have to be restricted to space for spinning habitats creating artificial gravity. So why shouldn't we have our first colonies on the moon be slowly spinning habitats like that? So maybe that's an idea to go away with. I talked about that with my friends, and they can't see any problem with it. So maybe our very first lunar colony will be a slowly spinning habitat on one of the peaks of eternal light. On one of the peaks of eternal sunlight. Right, so now after this I'm going to go on to start talking about other ways that we can colonize close to the Earth, and then I'll be getting back to Mars again and to ways of exploring Mars. It's a good time to break here.